Welcome, ladies and gentlemen. We are here in the production facility of EOS in Maissach. My name is Sebastian, product line manager of EOS, and I would like to show you the newest development of EOS, the M304. So come with me. Last year we introduced the M300 series. The M304 is the first system out of that platform. It's a completely new design platform architecture to reach the highest in serial production standards of the 3D printing. The heart of the M304 is the process chamber, and it's equipped with 4 lasers, 400 watts each. The laser beams are guided and positioned by a new generation of digital scanners. The scanners are arranged in the top of the process chamber, close to each other, to form the basis for innovative scanning technologies. We designed the process chamber completely new from scratch, for a laminar gas flow coming from left to right for a really smooth process behavior. The build platform is squared with dimensions of 300 by 300 millimeters. The build height is 400 millimeters. Two-sided recoating is possible to reduce the downtimes in between the exposures and to speed up the process. And now let's start a build job. It has never been so easy. Once the build platform has been inserted and the process conditions have been established in the machine, the new automated job start feature applies the start layer step by step in a very reproducible manner until the exposure of the first layer begins. The powder is applied by 2 recoater blades, one for forward movement and the other one for the return movement. The 4 scanners offer the possibility of a full field use. This means each laser can reach any area on the build platform. This results in plenty of possibilities for intelligent assignment of laser to component. One possibility is the arrangement in a quadrant form. This means 4 equally sized squares across the build platform. Another possibility is the arrangement in narrow path, so-called swim lanes, in which the lasers operate. In addition, innovative and new process parameters in EOS Print will make it possible in the future to further soften the boundaries of these fixed areas, so that all lasers work at any given time, thus enabling an enormous increase in productivity. And now let's have a look how the powder gets into the machine. The powder reservoir is docked to the rear of the machine in form of a separate dosing module, the so-called flexible dispenser. The connection between the process chamber and the dispenser is completely inerted. The flexible dispenser has a capacity of 80 liters of powder material, sufficient for any build job design. The flexible dispenser contains a lifting unit and a recoater. The lifting unit adjusts the quantity of powder, which was previously calculated by EOS Print. The recoater pushes this powder into the process chamber, where it is picked up and distributed by the main recoater. The amount of powder is always sufficient for 2 layers, the forward movement and the return movement in the process chamber. To achieve a fast material change, a second dosing unit can be used, and only a few cleaning steps in the process chamber are needed. The powder is manually filled into the dosing unit before the build job. The flexible dispenser can be also filled at another location and then brought to the machine and docked on the rear of the machine. Once the build job is finished, we have to unpack it, and this will happen in the transfer station. The build platform is attached to the platform carrier by the use of a clamping system. This is located in the exchangeable frame, which is equipped with overflow ducts in the front and the rear to collect the excess powder. The build platform carrier is equipped with a heating unit that reaches temperatures up to 200 degrees centigrade. As soon as the build job is finished, it can be moved out of the process chamber to the open transfer station. At first, the build job is manually unpacked by lowering the frame of the exchangeable frame step by step via pneumatic control. Then the excess powder can be conveyed out of the overflow ducts. The The build platform and thus the working level of the operator remains at the same height. The build platform is automatically decoupled from the clamping system and can be removed with a lifting trolley. Finally, a new build platform can be inserted. One of the most important components is the filtration system to keep the process stable. So let's have a look at it. As you can see to the left of the process chamber, this is the innovative filtration system. The newly developed gas flow carries smaller metal particles and condensate out of the process chamber and transports them into this filtration system. The filters are covered with limestone material before the process starts, so that the filter material itself is protected and efficient cleaning can take place. The limestone material is stored in a separate container and is continuously and automatically fed by the system. This results in a layer by layer buildup of metal condensate and limestone on the filters, which results in an intermediate passivation of this reactive material. As soon as a critical coverage of the filters is reached, the filters are cleaned automatically. The printing process is not interrupted by this. The material falls from the filter into a collection bin, which can hold several cleanings. Depending on the material used, the operator must replace the collection bin with an empty one in regular intervals, but after 70 hours at the earliest. The printing process is not interrupted in this case. For a safe further transport, the collection bin, filled with condensate and limestone, must also be completely passivated by adding sand and silicone oil. This is the EOS M304, the system with the best fit for serial production requirements. It's developed for high productivity processes with new innovative scanning strategies. If you'd like to get more details, contact us. Thanks for watching, talk to you soon, bye.